upfront, a short information from my side. I will start in a minute recording of the webinar, so this has kind of legal information for you. I'm really happy that today we start with a, as I think, very interesting topic, Internet on Things technologies, which will be presented by Andrew. Andrew is a product marketing manager from our automations and control solution located in Texas. And he will give us a very, as I think, interesting overview, starting from the basics of IoT all the way down to some cases which we already have in place. In case you have questions, please use the Teams chat function. We will answer and reply to it directly after Andrew terminated the presentation. And in case you have the need to communicate to us later, feel free to contact MKS directly as well. Okay, Andrew, the audience is yours.
Great. Thanks, Christian. Thanks for the introduction. Thanks, everyone. Good morning. Good afternoon. Appreciate the time to talk about some of IoT topics as well as some of the products that MKS has to offer in that regard. So just a bit of housekeeping here. This is going to be our agenda for the webinar today. So we'll review some of the kind of an introduction to technologies, some IoT communication protocols, which might be considered for production-like environments. Additionally, we'll talk about some multivariate analytics and a solution that we have at MKS in our ANCS business unit. Additionally, some information about our new industrial PC called the Hyperpack, and lastly, some new gateway functions that we've come out with, specifically targeting some semi and semi-like production fabs. So thanks for joining us today. So let's dive into kind of the introduction here. As far as the kind of the pillars of the IoT platforms, enumerated here. These are kind of the items that we feel that are, quite critical to providing a complete solution. So, there's got to be, the IoT gateway. This is going to be the thing, the device, the feature that that converts all of your information that you have in your environment, whether it's on a machine or in your fab. There has to be a thing that seamlessly connects all of your data so that you can pass it off to your next phase, right? And additionally, number two, you need to choose a method and a protocol that is common to either your hardware, your systems, your machines, your tools, as well as to your fab or your factory. And one thing that we've done, and we're going to talk pretty extensively a little bit later, is our business unit has decided to consolidate on the DDS, the Data Distribution Service IoT protocol, and we'll talk a lot more about that. There's a couple of bullets there, describing that. Additionally, once you have the information, it's really about doing more with your data. How are you going to be smarter? How is your process going to be faster, more efficient, provide higher yield? You're going to have to do some analytics, based on that. And where do you do that analytics? Is it going to be, as we describe, on device, or is it going to be more remotely? Maybe it's in the factory room, maybe it's in the factory itself, maybe it's in the cloud. You have to choose a method to do that. Typically, the closer you do it to the data source, to the sensor, to the machine, the faster that's going to be. And lastly, some sort of visualization. All the applications that you you and I will be working with, you have to have some way to interact with the data, some way to process and analyze and understand that information. So these are kind of the what we find to be the pillars of IIoT, Industrial Internet of Things. So let's dive a little bit deeper into kind of the IIoT bit of that, right? If you're talking at kind of the lower level, right? At the device level, and the device I mean by this sensor that's providing the data, right? So if you have some sort of process here, you probably have multiple machines. They could be the same machine. You could have a myriad of different kinds of machines. The manufacturers of the machines. And also the manufacturers of the sensors, they're not all going to be standardized on one different protocol. I have listed just a few here, and the list is already pretty long. There are lots of others out there. The ability for a user like ourselves to be able to choose one protocol and force and mandate our customers and our end users to be able to choose one. Not everybody's going to be at the same path in their roadmap to be able to provide that. So it's tough for us to be able to already try to choose one path. Going up one level from there, right? We have multiple machines in one factory. How about at multiple factories and multiple sites across either your continent or across a country? If you're looking to seamlessly integrate data, we have all of these different protocols to use. It's not going to be easy for even factories, between factories to be able to choose one, within one company to choose one. So there's lots of protocols out there that are maybe more difficult to use with, maybe more legacy, maybe more reliant on hardware, more reliant on some legacy controllers, legacy software, and so it's really not feasible to be able to take into consideration a consolidation on one. So here in the four quadrants of our page here, we have some of the leading IoT protocols. In the top left, we have AMQP, top right, CoAP, bottom left, MQTT, and on the bottom right, DDS, Data Distribution Service, as I mentioned earlier. And these are some of the leading IoT protocols out there. Many of them are used for consumer applications. Many of them are used for other production applications. However, amongst these top three that have the kind of the red X's on them, I've designated the red X's, the ability to be able to be used in production environments, right? That's what we're talking about here. If you can see the yellow and orange arrow here, it's all pointing to this. It's a thing. It's a server. It's a PC. It's a piece of hardware, and this piece of hardware is doing all of the data exchange, right? Sometimes it's called the exchange, sometimes it's called a broker, sometimes it's called a server, but there is a physical thing doing all of the marshaling of data, the processing of data. And you can see here inside the arrow, we have SPOF, single point of failure. So if this thing goes down, if it breaks, if it needs a Microsoft takes it and does a software update and breaks some of your processes and softwares, your factory goes down, your machine goes down. So there is a single thing doing the marshaling of data, and this represents a risk. This represents a risk. With DDS, you can kind of see the iconic image of the cloud, right? And although this processing is not actually done, by Google or Amazon, it's the thought that everything exists in real time, and that you can push data to the cloud, and you can subscribe data to the cloud, subscribe from data from the cloud at any time. And we'll talk a little bit more as the slides progress. But basically, it's been commonly termed as like Twitter for IoT. You basically you throw stuff out there, you can subscribe to things, and it basically when you get your feed, all of that data will come to you as only the things that you subscribe to. So some of the backbone of DDS, you can again see kind of the iconic cloud meme here. So DDS works in very complex networks. A lot of the other IoT protocols, you have a lot of work to do to set up what's called quality of service, and this has to do with what data you're subscribing to, the time update rate of this. It has to do with how many, in this case, retries. So if you're pushing data or pulling data, all of that has to be manually entered into your software code. Part of what makes DDS so great is that all of this is inherently built into the technology. It's a very fast, reliable, durable network that allows you to have security and speed, and it can process very large amounts of data. DDS is really a software-centric solution, whereas others are more hardware-centric, as we discussed, including others like OPC UA. It's a strong competitor to DDS. However, the OPC UA was really built with the software configured at the device level, whereas DDS has software built at the network level. So it's really, in our opinion, the best IoT protocol to use for production environments where you can see on the left-hand side here, this is really what it's good for. So if these things are very important to you, then DDS is going to be a strong candidate for you to use for an IoT protocol, and that's what we've standardized on in our business unit for a lot of our devices and in our progress. One thing that does make it difficult is it does require a lot of processing power, and that's easily overcome with with the device that's doing the hosting. So and as far as the applications are concerned, if you're thinking about speed, reliability, large amounts of data, these are going to be the best applications for you. That's going to be served by DDS. So very mission critical type processes, semiconductor, aerospace, semi-like solar, medical devices, automatic, autonomous driving, power generation, these kinds of things. So it's a real strong candidate for the data distribution service. So I wanted to give a couple examples of an application that we have devised using the DDS. In a semi-like environment, we have multiple process chambers running their application. We have a myriad of MKS and non-MKS devices communicating over multiple field buses. So in this case, in this example here, we have EtherCAT and DeviceNet, as you can see. And there are, and I'll kind of discuss here a little bit later, but that those two different field buses are being integrated into the the same central controller here called chamber controller. And from there, we do some gateway conversion. So we're going to convert these multiple field buses into our IoT protocol. And from there, we can push that to the cloud, and the cluster controller, which is going to be controlling all of the different chamber controllers up here, as well as some of the analytics that are done. Everything is pushed to the cloud, and each of these different devices can subscribe to that data and whichever data it needs, and be able to perform whatever process or analytics on it. So inside our gateway, you can see here we've kind of divided left-hand side from the right-hand side. From the right-hand side, we have kind of the ECAT side of the device, where we're interacting with the devices. So we're pushing data, we're writing data to the devices for control, as well as feeding data back into the EtherCAT master here. On the other side of the same device, we're going to have that data gateway, right? So we're going to be converting the EtherCAT information and others into the DDS. And so we're going to publish or write that data to whatever subscribers are going to be reading that data. So as we saw in the previous slides, maybe it's analytics, maybe it's control, maybe it's a SQL database, storing all the data. So here we have some of our performance for this particular application, and as described by our customer requirements. So we have some pretty large data packets being sent over the network, and the data rate at which we're able to push that data. And this is going to be on the left-hand side from the EtherCAT read to the DDS publish, as well as on the EtherCAT side, some rather large byte sizes. And this is, the performance, and this is really based on the EtherCAT frame rate. So that's some of our performance and, kind of how our application is run. And so looking at some performance of publish and subscribe data into both the shared memory space, which would be on the device, and this would be, I'm gonna jump back really quick. So the shared memory would be between the different sides of the same bit of hardware. So shared memory is going to be 1.5 milliseconds, and then across the network to a second device. So it's going to pull data from one device, push it across the network to a second device. And for both smaller data sizes and much larger data sizes, we get some pretty good performance. And that is going to be a combination of the use of DDS as well as the hardware device that we're using. And so this SDK is going to stand for Software Development Kit, which is an MKS homegrown ease of use tool to be able for the user to very easily basically set up your EtherCAT network, set up your DDS network, and be able to, using Visual Studio and a method and using a GUI, to be able to formulate and build your devices in your network using a the Visio plugin, as opposed to having to hard code that in your software. So it's pretty good performance for that. So leaving the IoT space, we're gonna look at some of our edge analytics solutions, and from a very high level, kind of the elevator pitch for our edge analytics product. From your industrial machine, we're going to be able to take the key process variables from that machine, much like the same process variables you're already interpreting and analyzing. We're going to do a little bit of filtering, do a little pre-processing of that data. We're going to analyze that individual process cycle in real time, and we're going to give you an output of a prediction of the quality of either the part that you're making or possibly the health of the machine or device that is in operation that's being monitored. And so, everything is in this situation is all networked. So you're going to be interacting with the system through Internet Explorer. So you'll have an IP address. There's an embedded multivariate analytics solution that's inside that's doing all our advanced edge analytics. It's, as I mentioned, everything is networked, so we're going to be able to push those results to the server. But as we mentioned earlier, we want to be able to do more with our data, right? So not only are we doing the analytics on the solution, but we're interacting with the machine to offload that data that falls below the reject line. So it's a complete solution. And really, in the ages of IoT, right? At the inception, there was a lot of data out there, right? There are trillions and trillions and trillions of data points being generated, every day. And so, really, we need to be able to, at the inception, right? Are you able to actually find something that happened? Are you going to be able to tell if something went wrong with your process? Is there a problem with the machine? Is there a process with the material? Where is the process? Next level up, diagnostics. Are you going to be able to tell why it happened? Not only are you going to be able to, number one, catch it, but number two, assign causality to the problem. And from there, can you fix it, right? Next, kind of where our edge analytics solutions lives is going to be in the predictive realm, right? We are going to be able to take that machine data, assign causality, and tell you if the part is going to be good or bad. How is the health of your machine? How is the health of your device? And this is really where the sense link is going to be living. As you can see our little moniker here, it says if you can model it, you don't have to measure it, right? So this is really great because it is a multivariate analytics. So what that means is it's not looking at one signal independently or two signals independently. It looks at all of the signals at the same time in real time, and you're able to identify patterns by performing the modeling. You're able to identify patterns and relationships and structures within the data, and we're able to predict either quality or as well as critical to quality components, say measurements or weights or colors or anything like this. And so in doing so, we talked about one of the large pillars of the IoT is going to be your GUI. And so as you can see here, you have the ability to set up upper bounds and lower bounds, so that if these green dots were to fall outside those quality limits, the system would reject that for you. And so that's really a very strong business case for the edge analytics, as well as a combination with IoT. So how do we move from there, right? So many of our edge analytics solutions are on premises, right? That means the controller is on the machine. It's doing the analytics right there at the machine. But what options do we have to move that analytics off the machine? Can we look at maybe a remote monitoring system? So if we have some sort of industrial machine, we have some sort of multiple types of signals, can we use a device to convert that to a different field bus or a different IoT protocol? Is this going to be EtherCAT? Is this going to be Industrial Internet of Things? But what we can do is we can offload that analysis onto a remote device. And so MKS does have an industrial PC, and when you're using that analytics, whether it's on premises on the machine, or if it's maybe in the factory room, or maybe it's at the factory level itself, by using the MKS controller, we're able to guarantee performance. We're able to understand the process space of the analytics and the performance at a much higher level. And in doing so, you may be able to, as you can see, this is our icon for our analytics solution. So you can run multiple instances of the same analytics on one controller. And that doesn't have to necessarily be on the premises of the machine. So moving up a little bit higher level, taking a further step back, offloading that analysis of the edge analytics further away from the machine, further away from the factory room. There are maybe software only solutions where as you can see, we're using the same data gateway. We're transferring it to an EtherCAT field bus or maybe an IoT protocol, and that can seamlessly integrate with multiple machines, multiple rooms in the factory, and possibly have all of that information go to one PC, one massive server at the factory, and where now we have twice as many monitoring solutions in the factory. Now this is very, I would say it's a little bit more seamless integration. However, you have now the risk of having the possibility of having the analytics go down if you have any network problems, right? If there's an IT problem, or if there's a server problem, you have multiple machines not being able to receive their information for control or analytics if there's a break in the line or the server goes down, and so that that can be a risk. Some people do choose to have the control at the machine level. Some of the benefits for the IoT solution of the edge analytics and the SenseLink and the SLQM, as we call it, it's really meant for to be able to offload the information more around the centralized management and control of multiple edge analytics solutions. So you can be able to control not only your data and the analytics, but rather specialized user and process level permissions, possibly analytics and reporting or visualizations, and those visualizations could be either individualistic per machine, or possibly aggregate those all into a single dashboard style. But the ability for expandability, scalability, using an IoT solution is a more robust solution to be able to scale and expand that information and to multiple devices, multiple machines and machines and processes across your factory, and possibly across multiple sites as well. And what it does is it moves the MVA and VID, which is virtual ID processing, which is basically our data pre-processing. But it offloads that resource from the machine to a server level, which may have a higher processing performance. And in doing so, you can additionally leverage the DDS and IoT Gateway performance. So next, just as a kind of an example of one of our use cases in this regard, we have interacted with some local PLC vendors to be able to write very specific software drivers to be able to have basically a VMware set up on an industrial PC, such that you can have multiple instances of the edge analytics running at the same time, connected to multiple machines. And what we've done is we have some performance metrics here, but you're able to connect up to in this case 32 different instances of the edge analytics just on one machine here. So some good metrics there. Right. So we talked briefly about some of the data aggregation. Here is an image from one of our application notes that we've written recently. And really what, it flows from bottom to top, as you might suspect. So we have, the factory and device levels down here. Each site has their, a certain number of instances of the analytics. And so what we've done is being able to offload the edge analytics information into, a file format that is able to be processed by one of our data partners. And in this particular case, we have a one massive server for all of the devices at all of the sites for all of the applications. And so this is a consolidation. And so these two steps here, we've been able to store the data and aggregate it. And additionally, our partner was able to build a reporting and visualization structure. So this is what our partner has provided. And from here, we're able to see that, in this particular case in North America for this case study, we're able to show that, each, dot is the location of the factory, kind of with some geocaching, and, the number of cycles that are being run is representative of the size of the dot. And, from here we can break down, based on, the file format and what information's in the file format to be able to filter and build very specific dashboards. And you can deep dive into this information to look at your performance or, what machine is being run. But it's basically your ability to be able to understand, on a global scale, what your factories are doing. Are there performance issues? Are there errors? So, just it's kind of being able to roll up that IoT information for something for you to use with. So next, I would like to introduce our the MKS Hyperpack, which is our offering for industrial PC. As you can see on the right-hand side here, it has it's very numerous I/O ports and connections. And you can kind of read some of the specs here. In the green arrows, I wanted to highlight some of its, kind of its key points here. The ECC memory, the ECC DRAM, this is error code correction. And basically this is a blue screen inhibitor. So if you have, one of those mission critical processes where if the controller goes down, excuse me, it's not a process you can easily recover from. It's not a process you can continue on once, you do a reboot. The error code correction, is that blue screen inhibitor preventer, and it adds to the reliability of the process. So of course, Xeon grade processor, server level processor, it's going to be, be able to be the workhorse you need for you. Next, the LTSB, which is the long-term service branch version of the Windows 10 IoT, it's going to require the fewest updates, fewest patches from Windows. It's meant to be the most reliable versions of the Windows 10 IoT that are out there, and it's really meant to support a lot of the newer mission critical processes, as I mentioned. Windows 7 is now end of life. There's no more patches. There's no more fixes. Any security issues that may reside inside Windows 7 are going to remain there going forward. And additionally, a lot of the newer softwares that are being developed are not being developed on Windows 7 anymore. Everything's going to be Windows 10 and beyond. So in that case, if you're going to be either retrofitting an existing machine or software or network, you're going to likely have to do everything on Windows 10. And that's what we've standardized here. Lastly is, we have multiple, I'm going to kind of jump over to the IoT Ready Solution. We have multiple open ports here, these three positions here for the mini PCIe cards as well as PCIe cards. It's really meant to be flexible for the user and use case. You can read, the ports here, but it's, all of the, multiple, and there's many other, blue boxes here that could fit into this equation, other field buses, but it's really meant to be, that IoT gateway for you. So it's able to take all Ethernet IP, type installations and field buses, as well as some of the more specific field buses, and convert those into something that you can use in your factory, whether it's IIoT or EtherCAD, but it's mainly meant to consolidate against a certain protocol for you. And as we saw before, there is really a very high reliability on this unit. So this is what we're using for our offering for reliability of control, as well as our IoT Ready Solution. Kind of our last topic that we're going to be covering here is going to be some of our use cases for our IoT gateways, and we can dive into a little bit more details into very specific cases. So in this case here, we have a semi tool. We have the image is a little bit small here in the text, but this is the MKS RGA, which is the residual gas analyzer installed on the vacuum chamber. And so what we're doing is we do have a legacy solution that is a gateway for a sex gem conversion. And that was at one point it was an actual hardware box, and it turned into a virtual box, and we've continued that solution, but we've made some improvements to it. And so what we're doing is it's a combination of data gateway. So we're taking RGA data, as well as we can take other information and convert it into the semi-specific sex gem protocol, so that the fabs solutions can, pardon me, so the fab solutions can host that information, as well as process and store that information. One thing that's a little bit advantageous is that not only are we able to convert that information into a fab specific protocol, but we're doing the VID mapping, which again is the virtual ID or data preprocessing, as well as data multiplexing. And what that really means is we're able to marshal that data and put a timestamp on it, and so that the information that is not regulated by the host or the machine, if you were to add a sensor or add a new device and it might not have the the sex gem protocol, we're able to consolidate that information into one data stream, put a timestamp on it, so that when it gets to the the fab host and all the FDC protocols that the factory has, everything is marshaled and everything is in line. So I think I've covered most everything of that. And so that's a software only solution that we're having, and we're going to be able to replace a very old solution that we have. Another two more cool gateways that we have are going to be a very simple sex gem conversion. Again, this is going to be a semi-fab in Asia Pacific, and there are as we all know quite some legacy machines out there, and there's constantly methods for attempting to improve the process, attempting to improve the control or monitoring, and in doing so, the OEM is very likely unwilling to add that information into their data stream, or be able to convert that external sensor that's out of their control that maybe an end user might be adding. And so this is one of those cases. We have a turbo pump vibration sensor that's being added to this semi tool here, and the customer wants to be able to monitor that vibration such that it can determine anticipate premature failures of that pump. So as the bearings get out of line, or the nitrogen casing possibly degrades, you're able to detect additional vibration or increased vibration, and in doing so, you might be able to predict a failure and replace that, because catastrophic turbo pump failure is pretty horrific to the process and to the machine. So in doing so, we're able to take that analog signal from the vibration sensor, using our, in this case, a hardware solution, which is a modular solution here. In this case, we're accepting analog inputs, and we're able to convert that information into valuable sex gem protocols, and that way the fab host can monitor that solution. So the next one is a very similar solution. There's a couple extra steps going on here. So, and in North America here, we have another customer that has again a legacy machine that's interested in adding a few different gauges around the machine, and one of them happens to be on the turbo pump exhaust four line going down to the basement, to the dry pump. And their interest is to predict and control, well, not predict, but be able to control and isolate the exhaust four line based on an increased pressure. So if the dry pump is about to have its own catastrophic failure, it wants to be able to isolate that pump and not have that uprush of pressure coming back up to the machine. And so by doing so, we're able, the sense stream, the MKS Pack Gateway here, it's able to basically write a very simple conditional statement that says if pressure is above X, take action and close the valve. And that way it's going to be isolating the process chamber from the uprush of pressure and possibly, breaking the wafers and damaging the tool and pressure gauges and things. Additionally, not only are we doing this conditional control based on a gauge, but it's also doing a data conversion to Modbus. So previously our application was analog to sex-gem conversion. In this case, it's analog to Modbus conversion, and the customer requested, that method of field bus data so that they already had their own conversion to their own sex-gem gateway. Lastly, a very cool IoT solution is, the ability for, field personnel to be able to provide some support in a, basically on-site, right, remote access, right? And so the ability to have the use basically a cell phone hotspot to be able to connect to devices on site in real time for customer support, and have the applications team on site and being able to communicate with the MKS experts that may be remote. It may be in the US, it may be in Europe, but being able to use basically a hotspot to be able to connect to both the device and the subject matter expert in real time is quite beneficial. And this is one approach we've been taking here recently. In this case, it happens to be with a butterfly valve T2B pressure control valve. So that is the conclusion of the presentation here today. I'd like to thank you for attending, and I appreciate your support. And Christian, if there happens to be any questions, we can discuss those now.
So far, no questions in the chat, but I have actually two questions. While you presented, the Hyperpack, one thing dropped in my head, which is a common situation we face with older products or older pieces of machines, which are, for example, running on old protocols like DeviceNet or analog. Is it, for example, possible using the Hyperpack or similar IoT tools to combine state-of-the-art control devices, like, for example, an EtherCAT MFC to an analog overall control system, or is that out of the scope?
Yeah, that's a good question, Christian. I think we have two different answers depending on what you want to do with the data. So, I heard your part of your question was data conversion. So in that case, I'm going to kind of jump back to a different product, but I might suggest that we use some sort of gateway only if we're only talking about data conversion. and it depends on what protocols we're going from and what protocols we're going to, because this would just be maybe an information gateway, right? Just data gateway. However, if we're going from like this device can also be doing the control as well. I might not suggest this as just a gateway for data, unless you want to go to like an IoT protocol. I think I might suggest the Hyperpack here for the IoT side, where there's the we call it the micronode gateway that we looked at in the previous slide. Might do just the data conversion. But there's definitely opportunities for consolidation of field buses, consolidation of conversion of data across multiple field buses, and that kind of integration.
Great, thanks. For the audience, please use the chat in case you have some questions. We're happy to share it. The second topic I have while you presented, or it popped in my head, is I mean, most of the use cases are really large-scale factories. I mean, the situation in Europe, especially in Southern Europe, is that we have a lot of smaller fabs which operate pretty traditionally. In case such operations like to change to IoT cloud approach, is there support from MKS possible, for example, for handling the data, for installing the DDS infrastructure? Plus, can you give a rough idea on let's say, cost? I mean, is this a topic which is bringing them to factor X on their annual operation cost, or is it dropping the cost?
Yeah, good question. You know, I would say that in this case here, you know, what we've done is, as you can see in, you know, some of the images here, we have, let's just call it 6 different process chambers. And so each process chamber will have its own controller. And so in doing so, you're going to have 6 controllers on this, you know, in this particular, you know, very specific setup. Now you can see here that each controller converts its, you know, field bus data to, you know, the DDS controller, the DDS protocol. And so in doing so, this, you know, one controller that's going to control the whole tool is going to be able to subscribe, you know, basically we call it subscribe to the information at each additional at each chamber. And so in doing so, you know, the IoT protocol doesn't necessarily have to be at the factory level. You know, it can still be at the tool level, and it makes, you know, integration, you know, and communication, you know, that much easier in that regard. You know, the DDS itself, it's free, right? It's you know, it's an open source type protocol. It's really the ability for you to buy the license to do the developing, if that's, you know, if that's in your wheelhouse. If not, MKS can help with you know, the integration of the DDS, especially to our, you know, controllers and our devices. The software development kits that I mentioned earlier, you know, the Visual Studio plugins, and, you know, what's known as an IDL file. It's very similar to like the EDS files of, you know, the DeviceNet era. It's basically going to have all your specs and setups for how you want the performance of your network and all the devices to be. We have a tool that bypasses having to write an IDL file and update the IDL file anytime you make any changes to your network. It's a great tool that saves hours and hours and hours of time having to redo that IDL file every time you change your network. So it's you know, being able to use the MKS software development kit saves you a bunch of time. Your cost is always an interesting topic. Typically we would license each additional controller. So if you had, you know, 6 controllers, you'd need to buy six seats. And it's very, I would say it's much reduced to, you know, having to buy something from a vendor to write your own code. You know, we kind of, you know, because we have, you know, our own license, we can offload that cost, and you know, the customer's impact is very low in that regard.
Great, thank you. Meanwhile, we have 1.5 questions from the audience. One is Bernd. Please, Bernd, since you're not writing it in the chat, just ask directly to Andrew. Okay, he's on mute. Oh, I just get from the organizer the information you have to write into the chat, Bernd. You cannot unmute. So Bruno asked, what is the basic configuration of the Hyperpack?
Sure thing. Let me jump back to that. Basic, where are we? Here we go. So good question. Basic configuration is going to be the processor, along with the chipset. We do have some flexibility to change out the RAM if you do not want the more expensive, more reliable ERAM. None of the I/O ports are populated, so EtherCAT, DeviceNet, and serial ports, those are all vacant. But the LAN ports, the USB ports, Windows is fixed, and you have the option of kind of a smart fan. As the system gets hotter, the fan gets more RPMs, or a fanless solution for if you have sufficient airflow across the. But basically, kind of a off-the-shelf PC as you might suggest or expect. So the server, the chipset, some memory, and none of the I/O populated. But the USB and the LAN ports will come with it.
Okay, speaking of cooling, it is not a water-cooled system, correct?
It is not water-cooled.
Okay, that's typically the first anxious question.
Yes, yeah, it's it's meant to operate in an enclosed environment. With operation of the fan. So if it's not in an enclosed hot enclosed box, that wouldn't be needed. The fan wouldn't be needed. Mm-hmm. But it's tough to guess where everyone's going to be installing it.
Okay, thank you. There popped up a question on what's the typical time we require in order to get the applications to run. So with the examples you presented.
Okay, let's jump down to these guys. So these are existing solutions for us. So I would, if you're thinking of like installation time, there would be lead time associated with the hardware, which is typically pretty quick, 4 or 5 weeks, to get the order processed and shipped out. But as far as the application support on site, it's a matter of a day to be able to, as long as we know what information is being requested, requirements are provided up front. It's pretty quick.
So for SenseLink, I recall there's a kind of training routine we need to run. Is it similar here, or is it just program code and get it started?
Yeah, the data conversion is pretty easy. It's very straightforward. It's just a couple button clicks. A few hours. So there's not like a training set. It's just data conversion. It's converts A to B. SenseLink, as you mentioned, the edge analytics bit. There is some inherent learning that goes on. Typically, the edge analytics products actually shows you more about your process than you knew previously, and so there's some learning that goes on. So what you thought you knew may not be the case, and so there's some inherent delay because of that. But additionally, it's more on the order of a week. Typically, we would be training and doing the modeling, and we'd run a design of experiments to build, define that process space, build a model, build those relationships, and validate the model. So that's all, within a few days.
So keyword is really hardware installation before we start.
That's right. Yeah, proof of integrity of the signals, accuracy of the signals.
Okay. Next question that popped up is, could you talk a little bit more about the USCAN semifab application and how that would fit into OEM examples? For example, like adding an analog baratron into a Siemens PLC / Profinet.
Sure. Could you repeat the question again? So you said in semi applications, data conversion from analog sensors into a Siemens PLC.
It's coming from a sales guy, so the question is really how, let's say, discussing it with an OEM, how would the approach be in presenting the integration of a system into a Siemens PLC here?
Okay. From what I think I understand about the question, it sounds like just another gateway. So in this very specific case, as I'm going to kind of jump between slides here, you saw that we have this this software driver already written for, in this case, 2 specific Siemens PLCs. And so in doing so, we can kind of ignore the application here in the way that the application is written. But we have a software driver for the Siemens PLC, and in doing so, we could, kind of replace this bit here where it says SexGem, right? So we can take, any sort of sensor here, analog, digital, temperature input, and convert that into, that same Siemens PLC driver for data, pushing data to Siemens.
Okay. Bernd, did you answer the question? Yes. Okay, great. Thanks for Markus and thanks for Bernd. Any other question, please feel free to put it into the chat. I'm more than happy to answer. Andrew, it seems like we are done. Many thanks. At least for me, it was one more learning session, and I hope for the audience as well. In case after we talk, any question appears, really feel free to contact us, either Andrew directly, as you can see his email here, or any from MKS as well. Okay, many thanks again. And in 4 weeks from now, we have next session on battery testing and what we can do with infrared spectrometers here. So another challenge, interesting topic. See you then and have a great afternoon. Thank you. Bye-bye.
Thank you, Christian. Bye now.